Hello guys, welcome to Coding. In this video, we are going to see the code problem number 931, minimum falling path sum. Let's get into the problem. So the problem statement is, we are given an enclosed array of integers matrix and we need to return the minimum sum of any falling path through the matrix. So a falling path starts at any element in the first row and chooses the element in next row, that is either directly below diagonal or diagonally left or diagonally right. So specifically speaking, the next element from position row comma column is nothing but row plus one comma column minus one, which is diagonally left element of the next row, and row plus one comma column which is the uh, element which is present in the next row below the current element, and row plus one and column plus one which is diagonally right element present to the current element. So that's all about this problem definition. So now let's move on to explanation about this problem. So yeah, let's get in. So the first step to solve any problem is to define the problem clearly. So the input for this problem is nothing but a matrix M cross N matrix. So the matrix is N cross N, and output for this problem is minimum sum of the falling path. So minimum sum of falling path through the matrix. So this is what we have to find. That is this is the input and output. So before move on to approach, we need to know some of the basic concepts like what is the falling path. So what is a falling path? So a falling path is nothing but a path from topmost row, top row to the, that is a path from topmost row. So the topmost row to the bottommost row. So this is all about the falling path. So the path which starts from the topmost row and ends from the, so ends at the bottommost row. This is the falling path. So what is sum of falling path? So this is the next thing we are going to discuss. So sum of falling path. So there may be many paths for given matrix. So yeah, so there may be many paths. Like if this is the matrix, let's consider a 3 cross 3 matrix. So the path may be anything. So the falling path is nothing but the sum of the elements in the path. So this is the sum of falling path, and we need to find the minimum sum. So the minimum is nothing but there may be several falling paths. So we need to return the minimum sum of the any falling path. So minimum of this sum of falling path. So this is what we are required to find. So they have given a condition. So what condition is nothing but from any cell. So let's say we have a matrix of 2 cross 3. So from this cell we can have three directions. So we can move from a cell to down or left or right of the previous to the next row. So from this cell we can go left, down or right. From this cell, that is our topmost right cell. From this element we can go to left or down. So this is all about the condition. So these are the direction we can move. Directions that we can move. There are three directions, which is left diagonal, down and right diagonal. So these are the directions which are given to us. So this is all about the problem definition. So now let's get on to the approach. So second step is the approach. So in this, so let's consider a matrix. So we are care about what is the falling path and sum of falling path and minimum sum of falling path. So you can see that from in order to reach this cell, we can reach the cell via above three elements. So this cell can be reached only through up or right or left. So left is there is no possibilities. So there is no element present in the left up. So we'll just consider top, that is up, and right up. So in order to reach this cell, we can reach this cell by from top left, up left and up and also upright. So this cell can be reached via top left, that is up left, up element and the, yeah, that's all. So there is no element here, so we'll ignore this. So this is the core logic which we are going to use in this approach. So one element, so each element can be reached from three of the possible ways, which is up, left and right. So this is the core logic. So how are we going to use this in our approach? So let's consider this matrix. So we can clearly see that the first row elements can be reached directly. So we don't need any of the above steps to follow. So we are initially at this row. So we'll ignore this row since we are already reaching the uh, elements in the present in the first row. So next, the path starts from the first row. So we'll ignore all these. So we'll move on to next row. So in this row, we need to find the number of possible ways. So this element can be reached from up or right up. So only these two possible ways are possible. So we'll just add the, we'll choose the minimum value. So the minimum value is 1. So we'll add it up to the current value. So current element will be added with minimum value. So in order to reach this cell, that is this element, we can reach it from up, up left and up right. So we'll choose the minimum element. So we need a minimum path sum, right? So we'll choose the minimum element, which is 1. So we'll add up 1 to the 5, which is resulting in 6. So we'll continue with the next element of the current row. So this element 4 can be reached from up left, up, and there is no upright. So we'll ignore this. So we'll choose which is the minimum value, that is the minimum value path possible to reach the 4. So the minimum path value is 1. So we'll add the 1 to the current element which is resulting in 5. So we'll continue the iteration to the next row. We have completed this row, the first row, which is directly the first element in the path. In order to find the second element of each path, we need to check for the second row, which we have done. And now we are moving on to third element of the path. So in third element of the path, so for each element we are going to find the minimum path which is currently available. So this element can be reached from top, that's up and upright. So we'll choose the minimum element out of it, which is 6. So we'll add 6 to the current value. So 7 plus 6 is nothing but 13. So this element 8 can be reached from up left, up and upright. So we'll choose the minimum value out of this, which is 5. So we'll add 5 to 8, which will be resulting in 13. So next we'll choose the uh, minimum sum path for 9, element 9. So 9 can be reached from paths 6 and 5, that is up and up left. So we choose the minimum, which is 5. So when we add it up, we'll get 14. So yeah, that's all. We have completely checked for each value. So what we have done is nothing but the minimum path value, sum path value, there is minimum falling path some value for each element. So in order to reach last element, last row, we need to come from the previous rows, right? So finally we have computed the minimum path sum to reach the bottommost row. So from this we can return the minimum value. So finally the minimum value will be 13. So this is these are the answers. So let's check this up. Yeah, 13 is the answer here. So this is all about our logic. So now we are going to see intuition. So intuition is uh, will iterate over each row and find the minimum path, that is minimum falling path end. So that is tail. Let's call it as tail. So we'll find the minimum path tail at which directions? It's nothing but we check over up left, up and upright. So we'll check in these directions. This is the intuition, and we'll firstly find the minimum falling path sum and add it to current path. So add to current element. So when we add this value to current element, the current element will be becoming the tail of the current any path. So we have reached till now. So we are going to continue this iteration till last row. So when we reach the last row, we'll stop the iteration and return the minimum value, that is minimum path sum, minimum falling path sum at last row. So this is all about the iteration. So let's discuss about the time and space complexities. So time and space complexities. So the time complexity of this approach is nothing but we go of n cross n since we are iterate over each element, and the space complexity, so which will lead us to big O of n square, and space complexity is nothing but big O of 1 which is constant. So that's all about the time and space complexity. So I think you are getting some idea about this approach. So if you are not clear about this approach, don't worry, you'll get a clear idea in the coding session. So let's move on. So initially, first step is to iterate over each row starting from 1, that is second row, till last row. So we'll store the row n, which is number of rows in variable n, matrix start with. So matrix dot length will give us the number of rows present in the matrix. So we'll be storing this in variable n. So we'll be iterating over each row, and firstly we'll check for the top left up. So after this we'll iterate over each column. So we'll be using variable j to iterate over each column. So column will be starting from j 0, and we'll go till n minus 1. So we are using n as the uh, boundary. So we'll iterate over each column. For each column we need up left value, up value, and up right value. So we can check up value. So up value, there are three values, that is SL. So when we get into this loop, that is second for loop, we get the values I comma j. So our current element is nothing but I comma j. So if you are at current I comma j, what will be the up element? So up element is nothing but I minus 1 comma j. So what will be the uplift element? Uplift element is nothing but I minus 1. So we are decrementing the row and column. So column is decremented by 1. This is the uplift element. And upright element nothing but I minus 1. We are decrementing the row. So previous rows next, that is when we increment the column we get the right. So upright. So these are the values. So we'll find the minimum path. So let's say minimum path sum. So we'll say current minimum path sum. So current minimum path sum is nothing but matrix of I minus 1 comma j. So we'll consider the current cells, that is current elements minimum path sum is the up element. So we'll check for other elements. So there are cases in which uplift element and upright element doesn't exist for any of the element. So in this case we need to ignore that. So we'll check if the j is 0. In this case we don't have uplift element. So in that case we'll skip this. So in other cases, if j is not equal to 0, we'll compute the minimum path sum. So in order to do that, we'll compare with the top element, which is, so we'll find the minimum. So it's nothing but the min of current minimum path sum comma current element, that is uplift element. So uplift element is nothing but matrix of I minus 1 and j minus 1. So let's check the uplift element. Now we are moving on to computing the minimum with by comparing with the upright element. So if upright element doesn't exist if j is equal to n minus 1. So if the column is the rightmost column, we don't have any right element. So in that case, we don't check with this. So in other cases, if it is not the last column, what we'll do is we'll compute the current minimum path sum, like nothing but method min of current minimum path sum, comma, matrix of previous row and right column. So yeah. So finally, what we'll do is just add this up. So matrix of I comma j. So current element is added with the minimum path sum. So current minimum path sum. So we have done it. So what we can do is finally we'll be able to compute every value, that is uh, every falling path sum. So we'll have a variable called minimum falling path sum. So we'll initially set this to matrix of n minus 1 comma 0. So what I have done here is we'll initially choose the last row's first column as the minimum falling sum. So in this case, yeah, I firstly I'll choose the minimum falling path sum as last row's first column. So we need to check, compare and check the other columns, right? Other columns of the last row. So in order to do that, we have I as n minus 1 and j as which will be iterated from 1 till last column. So j is used to iterate over columns. So minimum fall for some nothing but method min of minimum fall, so for some, and current element. So current element is nothing but matrix of I comma j. So this will give us the minimum path sum of the current cell. So finally, we'll be able to find out the minimum fall path sum. So we'll return the minimum fall path sum. So that's all about this. So what we have done is firstly we have taken number of rows and stored it in variable n, and we are iterating over each row of the range 1 to n minus 1. So for each row we are going to check, uh, we are going to find the minimum path sum, current minimum path sum. So in order to find that, we are storing the up element of the current, the element which is present above the current element, and we are declaring it as current minimum path sum, and we are checking for up left and upright diagonal elements, and we are comparing with the current minimum path sum, and finally we are adding the minimum path sum that is available and to the current value. So after doing this, we are going to take the last row's first column value as the minimum path sum, and we are going to iterate over each other columns of the last row, and finally we are going to return the minimum fall path sum. So let's take this up. So it's working fine. So let's submit it up. Accepted. And that's all about this video, guys. Thanks for watching this video and have a great time.